In this video, let's see how can we add node and edge features to the homogeneous graph. So within DGL, we have two interfaces to do this task. We have something called ndata, which refers to node data, and we have edata, which refers to the edata. So before looking at these interfaces, let's try to understand the example graph. So I constructed a simple graph with 4 different edges ranging from 0 to 3, and this is a directed graph with 5 different edges. So unlike the previous graph, along with the nodes and edges, I also added some information at nodes and edges. Okay. So along with the nodes and edges, we also have a three-dimensional vector at every node and a scalar value at every edge. So now let's try to build this graph using dgl functions. Okay. So first I'll create this directed graph using the source node IDs and the destination node IDs. Okay. So we have already seen this in the previous videos. So we use dgl.graph method, which accepts the tuple of tensors. Okay, it accepts a tuple of tensors where the first tensor refers to the source node IDs and the second tensor refers to the destination node IDs. So we already know what are the source node IDs and destination node IDs from this graph. So we just need to pass these two tensors as an input to the dgl graph method. So once we pass this, so we'll get a graph. And if you observe this graph object, we can see that the number of nodes are equal to 4, which is ranging from 0 to 3, and the number of edges are 5. Okay, even in the graph that we have here also, it contains 5 different edges. And if you observe here, we have two more things, something called ndata schemes and edata schemes. Okay, so right now we can see that both the ndata schemes and edata schemes are null because we haven't added any node features and edge features. Okay, so now using the ndata and edata interfaces, let's see how can we add these node vectors and some weights on the edges. Okay, and there is one thing to note here. So whatever values that we add for the nodes and edges should be of numerical types. That is, you can either define the values to be of float, double, or int. Okay, only the numerical type values are allowed. And again, like I mentioned earlier, we can either have the scalars, or we can have the vectors, or we can even have the multidimensional tensors for every node and for every edge. Okay, it's up to us. We can define whatever dimensions we want for the edges and nodes. So now let's just try to replicate these vectors for every nodes. Okay, so it's very simple. So we have graph.ndata interface. First, I'll just print this graph.ndata and let's see. As you can see, it's empty. It's empty for now because we didn't add any data at a node level. So now I wanted to add these vectors at every node. Okay, so I'll just name this as node vectors. Okay, I'll just name this as node vectors, and this can be any name. It's up to you. It's a user defined name. Okay, so I'm creating a new ndata with node vectors, and within this, now I wanted to assign a node vector for every node. So how many nodes do we have? We have total of 4 different nodes, right? We can even print that and see. Let's print graph.nodes. Okay, you can see the nodes are ranging from 0 to 3. So for every node ID, we wanted to add a 3-dimensional vector. Okay, a 3D vector. So let's see how can we do that. So I'll use a multi-dimensional tensor to do this task. Okay, so first I'll define torch.tensor, and I wanted to add a 3 valued vector for every node, right? And how many nodes we have? We have 4 different nodes. So I'm going to create a tensor of tensors, something like an array of arrays. So okay, first for node 0, I'll just create a vector with 3 values. Similarly, I'll create a vector with 3 values for node 1. I'm randomly just defining these numbers just for the case of demonstrating this. So again, like 3, 5, 6, and again 7, 8, 9. Okay, so this is the tensor that I have defined. As you can see, how many rows do we have? We have 4 different rows because we have 4 different nodes in the graph. And how many columns do we have? We have 3 different columns because each of the node vector is of 3 dimensions. Okay, so we created something like 4 cross 3 matrix. Okay, even we can see the shape of this tensor. We'll see that. So first I'll add this tensor to the graph. Okay, so now I'll print the graph again. Okay, I'll print the graph again. So now when I print the graph again, you can see now the ndata schemes is not empty. Okay, so here we have added some scheme with the name node vectors. Okay, so now how can we access this? And this is very similar to dictionary. We can just access this with the key value, that is the scheme key value. So what is the key value here? It's node vectors. I'll just print this. Okay, so you can see it returned a tensor that we have created, that we have passed as an input to this node vectors. Okay, let's try to see the shape. Okay, so we can see this is a torch tensor of size 4 cross 3 because we have 4 nodes where each node is having a 3-dimensional array or a 3-dimensional vector. Okay, so it's a 4 cross 3 matrix. Okay, that's how we can create or we can add the nodes level data using these ndata interfaces. Okay, and similarly let's see how can we add edge features. Okay, so again here I just wanted to add the scalars at edges. For now I don't wanted to add any vectors. I just wanted to add some scalar values for every edge. Okay, and how many edges do we have? We have 5 different edges. Okay, let's just try to print the edges. Okay, so let's try graph dot edges. Okay, so this will return us the source node IDs and the destination node IDs. So I'll just put form is equal to all. Okay, so this will return a triple. You can observe the third tensor in this triple, which is ranging from 0 to 4, which says we have 5 different edges whose edge IDs are ranging from 0 to 4. Okay, so now we need to add some edge value for each of these edges. And similar to the previous approach, we can use graph.edata in place of graph.ndata. First I'll print graph.edata. Let's see. So this is empty because we haven't defined any schemes for the edata. So now I wanted to define something on the edges. I wanted to call them as edge weights. Okay, because these are not really vectors. I just wanted to add a single value at every edge. Okay, and we can again use the torch.tensors. So here, as it is a scalar, we don't need a multi-dimensional tensor. I'm just considering a simple list, kind of a list, a simple 1D tensor. And how many values we can have here? The number of values in this tensor should be equivalent to the number of edges in the graph. We have 5 different edges. So I'll define 5 different weights. Let's say 100, 200, 300, 400, 500. Okay. So now I'll just run this. Okay. So now I have added the edge weights, that is the edata. So now I'll print the edata. First I'll print the graph. So now when you print the graph, you can see now the edata schemes is also not empty. It has a new scheme with the name edge weights. Okay, and again we can access similar to dictionaries, graph.edata of key name. Okay, edge weights. Okay, and you can see this is a tensor of weights. Okay, so this is how we can add the node features and edge features. We can use dgl ndata interfaces to add the data at node level, and we can use dgl edata interfaces to add any data at edge level. Okay, thanks.